the things that you shouldn't be doing, and things like that. Okay, so when I go through these, I'm going to do the simplest way possible. If that's not the way you did it, that's okay. As long as we have the same answer, we're good for these first two. So 196 is a perfect square. Some of you realize that, some of you didn't. That's okay. But you should have had 7 and 2 if you did factor tree. Then I'm just going to use the rule, because that would be the fastest way to go about doing this. 2 goes into 3 once, with 1 left over. 2 goes into 4 twice, with nothing left over. 2 goes into 9 4 times, with 1 left over. So on the outside, you should have 14x y squared z to the 4th. On the inside, you should have x and z. For the most part, a lot of us got that one right. I didn't see a lot of issues with that, except for maybe when you broke down 196, you may have gotten like 7 and 7 and 2 and 2 and put 49 or something that wasn't 14 on here. So just be careful with that. Make sure your order is correct. Do we have any questions on that one? You're not sure about something, you're not sure why something is wrong, anything. For number 2, the most common problem I saw was if you were doing factor tree method, you started doing pairs and not groups of 3. This was a cube root, so you should have been doing groups of 3, not pairs. That messed a lot of you up. So also, the negative should have come out. Some of you forgot that, so I'm going to do that first. So I'm going to use perfect cube for this one because 64 and 2 work. This would come down to be 4. This would stay the cube root of 2. And then again, I'm going to use the simplest method possible. It's okay if that's not the method you used. 3 goes into 9 3 times with nothing left over. 3 goes into 11 3 times as well. But then there are 2 left over. If you were doing the rule, some of you forgot the 2. If you were doing the factor tree method, most of you got the 2. So then on the outside, we have negative 4m cubed n cubed. Make sure you're putting the index, the 3, on the outside. And then on the inside, 2n squared. Do we have any questions about that one? Not sure about something, not sure why something is wrong, anything like that? So for the most part, the first section was really good. It was the second section. So with this first one, I think more problems with 3 than 4. A lot of you knew that area is multiplying. So you would write it like this. But if I'm multiplying, I'm not just multiplying one thing and one thing, I'm multiplying everything together. So if it helps you put the parentheses, that way you know you're multiplying this to both things, not just one thing. I think that's where we messed up a lot, or I saw a lot of mistakes. If you need to draw arrows, color code, whatever, to help you determine what gets multiplied together. So in this case, outside things go together. There's a 1 out here. That will also go together, multiplied together. Inside things will also get multiplied together. But when you multiply these two things together, this is next to it. So we have to also bring it next to it. We can't just leave that by itself. So on the outside, 5 times 6 would give us 30. This is next to it, so you have to drag it along. Then for the next part, on the outside, 5 times 1 gives us a positive 5. On the inside, we have the square root of 150. I saw a lot of 30 times the square root of 150, but we should have two separate things if there are two separate things here. Questions, confusion, anything like that so far? Then you could break this down. Again, I'm using the simplest method, so 25 and 6 work. This would give us 5 times the square root of 6. We would have to bring down this 5 and multiply. So after we multiply, see if we can simplify. And we can't because we don't have the same insides. Some of you got the same inside because of how you started, which I saw, but we could not add these. If they were the same inside though, we would only be adding the outside numbers. The inside number would stay exactly the same. Yes?
Input for 3, is that like a 75 or a 25?
It should be a 75.
Also, can you re-explain the part after the second row?
Right here? Okay. So we're breaking down 150. So instead of using the factor tree, I'm using the perfect squares. Highest perfect square that we can divide 150 by is 25. And then 25 times 6 will give us 150. And then the square root of 25 is 5. And I would just write that down. Any other questions on that one? Emo.
How do you know 6 goes in that, like, it's outside? Or, like, it always goes outside?
Oh, right here. Yeah. If it doesn't have a radical next to it, it's considered outside already. You can, I was going to say pretend that there's a radical with 0, but that would just be 0 and that would go away. So there's not a radical, so it's automatically outside. We'll stick with that one. Other questions on that one? For this next one, a couple issues I saw. One, some of us tried to add the two things together, but these insides are not the same. Even though they both have the x to the third, one is 8, one is 18. So because the insides are not the same, we could not add them together. I saw something else, so I'm going to do it the way some of you did this, where you simplified these two. I'm going to use perfect squares again. But you didn't simplify the x's here. And it's okay if you don't do this right now and you do it later, but some of you didn't do it later. So some of your answers look like this. 3, not 2. Where you had 10 times the square root of 2x to the third and 9 times the square root of 2x to the third, which again, so far is fine, and you combine them, but this cannot be your final answer because it's not fully simplified. Your variables are not simplified.
So it means nothing x, the square root of 2x.
Yes, that was your final answer.
That's
Right? So you don't have to simplify the variables at the beginning, that's fine, but you do have to do it eventually. Whether you do that at the beginning, at the end, does not matter. That was the major issue I saw with that, besides trying to add them at the beginning. anything else. If you had variables outside that were not the same, or you had like x and x squared, those again would not be like terms because we have different variables or different exponents, even though the inside is the same. Keep that in mind. Do we have any questions on this one? Anything we're confused about? Anything like that? Take out your review. We're going to go over any last minute review questions you want to go over before we go to lunch. Yes, that one. It looks like this, but it doesn't say 11. Whatever yours says, I think it says the correct one. What questions do you have, want to see, want to go over, anything like that? Anywhere. And my numbers might be different, so on this page, or the second page of that, my numbers might be different. This one. Okay, for this number 11, we are distributing to multiply, then add at the end. If you need to see what's inside, what's outside, there's a 1 out here, there's a 1 out here. We're multiplying that 1 to 4, that 1 to 1. Then when we multiply this square root, there's nothing to multiply here, but it's just going to get dragged along, and those two are going to multiply. So it's going to look something like 1 times 4 is 4, but because this is next to the square root of 3, we're going to add, maybe not say that, we're going to put the square root of 3 right next to it. 1 times 1 is positive 1. On the inside, I would be multiplying 3 and 15 to get 45. Then your adding and subtracting rules come into play. You can't add them right now because they're not like radicands, they're not like terms, whatever you want to say there. See if you can simplify this. You could have done that either way, perfect squares or factor tree. Take whatever your pair is out. So 4 times the square root of 3 plus 3 times the square root of 5. These, again, are not like terms, like radicans, whatever. That would be your final answer. There's nothing else for you to do. You can't simplify in any shape or form. Any other questions you want to see go over, Nature? This one. For number 2, we are simplifying. However you want to do that. So I'm going to do perfect squares. 16 is the highest perfect square. 2 goes into 9 4 times with 1 left over. 2 goes into 2 1 time with nothing left over. If you want to put the 1, you can. You don't have to. 2 goes into 25 12 times with 1 left over. So on the outside, we would have 4, a to the 4th, b, c to the 12th. On the inside, we would have 5, a, c. Other questions we want to see or go over, or have questions about? Cameron? 12. On this page, I will say nothing like this will be on your test. You still want to go over it. So something like this, you would have to know that anything squared is itself times itself. So this is the same thing as 8 minus the square root of 2 times 8 minus the square root of 2. Then it's very similar to where we have to distribute everything twice. So we would rewrite it first. The very first term times everything in the second. The second term times everything in the second. After you rewrite, then you start to distribute. Okay, so here we have outside things. Here we have outside things and inside things. 8 times 8 would give us 64. 8 times 1 would give us negative 8, but it's attached to the square root, so we have to bring that down. Negative 1 times 8 would give us negative 8, but this is attached to the square root, so we have to bring that down. Negative 1 times negative 1 would give us a positive 1. But on the inside, we have 2 times 2, which would give us 4. Then start to simplify. Combine your like terms, see if you can simplify radicals, all of those things. So I'm going to do 2 things at the same time. Combine these 2, because they are like terms, as well as simplify this, because the square root of 4 is 2. Then you have one last pair of like terms you can combine, 64 and 2, to give us 66 minus 16 times the square root of 2. And that would be your final answer. Other questions we want to see, go over, have questions about? If we don't have any other questions, before we go to lunch, start getting those papers together. If you're not sure about what is what, let me know. Make sure you get the binder check from last time also. Put that with your papers.